Wind energy has been harvested by humanity for thousands of years. Originally, windmills were used to crush grain or pump water, whereas modern systems use turbines and produce electricity. In 2021, wind energy supplied more than 9% of all US electricity generated. However, basically all of that was generated using traditional wind turbines with blades. Due to demand outstripping supply, energy prices are increasing, and this is making more homeowners consider harvesting their own energy from renewable sources. So currently, photovoltaic solar panels make up nearly all of the renewable energy capacity of residential homes. And whilst building legislation and space limitations prevent traditional turbines from being used residentially, there is an industry developing from a gap in the market, where that gap is wind energy that is generated residentially. And that gap is being explored by bladeless wind turbine technology. Currently, there are two ways to generate wind energy, which is rotational wind harvesting and oscillation wind harvesting. Rotational wind harvesting is a traditional method in which turbines rotate, which turns a generator and thus generates electricity. However, these turbines often require a lot of space and are relatively expensive. On the other hand, oscillation wind harvesting involves making use of when air flows across a cylinder. When this happens, the cylinder will resonate as the frequency by which turbulence behind the cylinder is generated meets the natural frequency of the cylinder. And vibrations induced in the cylinder lead to the linear motion of the cylinder, and then that linear motion is used to generate electricity. Currently, there are two main players in the development of bladeless wind turbine technology, and those are Aeromine Technologies and Vortex. Aeromine Technologies is a startup company located in Houston, Texas, that was started by Texas Tech University professor Carsten H. Westergaard. The system uses rotational wind harvesting and works as when air flows past the wings, an area of low pressure forms between them, and an aerodynamically shaped tower placed between the airfoils feeds the suction created by this low pressure through pipework so that it pulls air past a small turbine in the unit's base. As this turbine spins, it generates electricity. The first pilot program has been deployed in partnership with BASF Corporation in Michigan, and there are negotiations to produce tens of thousands of units by the end of 2023. Vortex was started in 2014 by David Yanez and Raul Martin, who were inspired by the Tacoma Bridge disaster of 1940. Vortex turbines use oscillation wind harvesting such that when wind bypasses the structure, that mechanical energy is transformed into electricity. And whilst I couldn't find any information released from Vortex regarding when they expect to have any products commercially available, I did find an article on Murcia Today which suggested it would be at least another 6 years from now before any product would be available to buy. The main draws to bladeless wind turbines are the reduced maintenance due to there being a lower number of mechanical parts, the fact that the systems are expected to be safer and quieter than traditional turbines, and also that the systems will generally occupy less space. And all these points make bladeless wind turbines a prime candidate for a home system. However, there are also drawbacks associated with bladeless wind turbines, and the main drawbacks at the moment are the technology's maturity, such that most bladeless turbine technology is in early stages of development, and there are currently no systems commercially available. Also, the generation technique. In the case of oscillation wind harvesting, energy is converted to an electrical form from a translation motion, which is inefficient compared to rotational energy conversion in traditional turbines. Also, there is likely to be higher costs per kilowatt hour produced to offset the long time in developing the technology. Ultimately, it is very difficult to top or even match the energy output of traditional turbines. Christina Archer, the director of the Center for Research in Wind at the University of Delaware, said that airborne systems won't replace conventional wind, but it is possible that they do have their place within the wind power generation sector. In urban areas, wind speeds are typically very low, at least close to the ground. In these same areas, fast-moving turbulent air is found higher up in the altitude, for example, towards the top of skyscrapers. A potential future solution is for future buildings to be designed considering this. If that fast-moving turbulent air is funneled into the building, could it be used to turn a turbine within the building, thus generating electricity? This solution is food for thought, and I would love to hear what you think about it, and if you have any other ideas for how we can utilize wind in urban areas. As for the future of bladeless wind turbines, I can see the potential for them being used in the future, but as explained, there is no commercial options turbines currently available, which is not exactly promising. I thought I would get a second opinion on this, so I asked ChatGPT, a large language model chat box developed by OpenAI, what it thought about the future of bladeless wind turbines, and here I present to you its answer, which indicates that despite the challenges associated with bladeless wind turbines, there is still significant interest in developing and improving them, which suggests they could play a role in the future of renewable energy. I hope you enjoyed the video. Please do engage with it. I would love to get as much feedback as possible. Furthermore, I recently started a subreddit to discuss green future ideas, which is r/rgreenfuture. Please do contribute to the subreddit, and the most popular discussions from the subreddit will feature on the YouTube channel in future videos. Thank you very much.